many of you run Edge as your primary browser all the time? So both of you, great. Glad to hear that. How many of you want your users to use Edge all the time? How many of you have asked yourself the question, in all seriousness, in my organization, I wonder how we can have IE not only be the default, but block users from ever using Edge? Handful. That's kind of where we are. What we want to talk about today is where is Edge, where does it fit in, and why should I make it my primary browser? Now, I have a bit of a confession to make. I'm a nerd. And the conversation we're going to have is all about all of the nerdy things that you should like in Microsoft Edge. Why is it good? How does it work to take all of the marketing speak, and in fact, I am going to take a marketing deck as the foundation and go under the radars and really explain what these things are so that you can understand it, right? Really understand, hey, this is something that hopefully you'll agree is really good and that I want to start using for more and more scenarios. Certainly not all of them. I would say it's aspirational that the web should work regardless of device, regardless of browser. That's very important. But on a Windows device, I'm hoping you'll get to the point where you agree that's the browser I'm going to want to choose. Maybe not for everything, but certainly for a lot of really important scenarios. That's where we hope to get. How do I get my stuff to work? And why do I, as a nerd, think that this is the most secure place to be? Now, one of the things that I found a bit curious as I was looking over the name of my own session is that, I don't know if you guys have noticed this, every single session at Ignite begins with a verb. Did you notice that? Every single one. Now, we didn't submit them with a verb at the beginning. They just added them. And they picked kind of a boring one. So I thought, that's not what I would have picked. Like, if I had to pick a verb, I'd probably pick that verb. Right? So you're getting jiggy with Microsoft Browser Security. Or perhaps keel-hauling Microsoft Browser and Security internals. The other idea I had about how I would have the walk-in slide would be maybe actually have it be a web page. So I designed this curious thing. Interesting thing, this is actually running on Microsoft Edge. This works on the modern web. How many of you are web developers? So a handful. To show you what it's like, it turns out that one attribute I really wanted was the blink attribute from older versions of HTML, which are no longer supported in HTML5. But it does turn out that with CSS3, you can actually implement your own blink using CSS3 animations. And so that's what I had. That is how much work I'm willing to put in for you, the audience, is to create brand new animations so you can enjoy a site like this. So you're welcome. In the end, the important thing is we really want to make sure we understand what's going on, go beneath the covers, and start taking a look at all of the buzzwords we keep throwing around, but we fail to explain. I want you to understand it. I want you to, if you're looking at other code, be demanding that they start using the exact same thing. But let's start with getting to Edge in the first place. So I'll tell you where we'd love you to be, and then we'll talk about why we'd love you to be there. Here's where we'd love you to be. Edge is the default on your Windows devices, and you will bounce back to IE when you need to. That's where we'd love to end up. Question is, how do you do that? Because there's still all kinds of content that doesn't work in Edge, particularly in the enterprise, right? When you look at some of the enterprise numbers that are taking place, and it's been about a year and a half since I last looked at the numbers now, but it's kind of a staggering statistic. When we look at what happens in the enterprise web, 70% of enterprise web applications run in IE5 Quarks mode. 70%. That's a 1999 implementation of web standards. That, by the way, does include the blink attribute, so we don't need to make our own. 70%. It's staggering how much of the web, the legacy web, still exists in the enterprise today. And it exists that way because the default group policies for IE said, hey, run everything in compat view. We started that in IE8. That said, behave like IE7. That's the default for the local intranet zone. As the default, unless you push the get out of jail free card and stop using that, you'll be creating brand new content designed for the legacy web. Bad news. And you get into quirks mode because you didn't add a doc type declaration. The doc type declaration is something you have to do to escape. Otherwise, you get the default of quirks mode. So the defaults push you as far back as possible, right? And that's what we've got to reverse. So how do we deal with compatibility? Because we're dealing with a legacy web, a lot of history, up to and including the fact that, yes, indeed, we're still tracking the demise of Internet Explorer 6. I don't know if you visited this page lately, but there are still parts of the world in which that's a problem. We're still dealing with websites that look kind of like this, right? When you think, what does a legacy web look like? That's Microsoft's 1994 website. And we're still dealing with sites that do behaviors like this. This is the conflict. This is the legacy web and the modern web colliding. The old way of default to old and opt in to new is giving way to the new way of default to new and opt in to old. And that's where we'd like to get. How do I only use new stuff? Because it turns out that this website, it's fascinating how it's broken. The reason this website is broken is because it's using modern technologies, but it ends up in compatibility view, where those modern technologies don't work. Now, if you ask, well, why is that incompatibility view? It turns out it's incompatibility view because the developers, for some reason, asked for it. Please don't use any modern web technology, but then complain when you can't use modern web technology and say Internet Explorer must suck. You know, it turns out it works just fine if we say, you know what, just run this in what you would have defaulted to anyway. What is going on here? Oh, that's pretty awesome. Why won't my F12 tools get out of the way? All right, well, now they're out of the way. It works just fine. It just chose not to go just fine. But that's kind of the starting point that we're in. We have the legacy web, the modern web colliding, and the new paradigm is default to new and opt into old. So the question is, how do we go about opting into old? And that's where we have the enterprise mode site list. So the enterprise mode site list is a way to express in XML, these are the sites that need this legacy compatibility mode. So it can not only take me from a default position of edge and bounce me back to IE whenever I need to, but it can take me from a default position of IE, which goes to 11, and duck me back to whatever mode I need to go. It's actually been one of the most successful application compatibility technologies we've ever seen. Right? And folks who have used it, there's a handful of websites that have such weird little persnickety things. Like one of them, for example, is there's an infragistics control, a version of which that changes in how we handle the prototype chain in the Chakra JavaScript engine, change the behavior of the web because they made some very strange assumptions, and we can't change Chakra to accommodate that. Right? There are a couple. But other than that couple, it's literally, I can count on my hands how many sites we've not been able to fix. It's all a matter of configuration. How do I get it configured to point to the mode in which it works? And that's through a site list. This site list says, run this in whichever browser. So you can see it's like, open this guy in IE11, and then within IE11, run it in enterprise mode. And now I can do a full configuration and push that out through group policy. So I don't rely on my users to pick it. I can just say work by default. And we've actually been doing a lot to improve the experience. So let's go ahead and take this. We'll actually go ahead and use this. This was created using the site list manager, as you can see from the tool section here of the XML. And I've written a couple of PowerShell scripts that allow me to set it. Because within Microsoft, we use this liberally. We have plenty of sites that still only work in Internet Explorer. They don't work in Edge. In fact, one of the big complaints that our Edge team has is that our career site where you apply for jobs only works in IE. So in order to apply for a job on the Edge browser team, you have to use IE, which makes them very sad. So we have one. So what I'm going to do is use a script that's going to just go in and punch these registry entries on top of what came down through group policy, because I'm a local administrator, which means I should probably be running this as a local administrator, or it's going to fail. So let me go ahead and close this so we don't just watch it spectacularly fail and learn how to run things as admin. Open up our PowerShell window and open up this script. This, by the way, is why you should not make all of your users local administrators, because then all of your group policies end up being suggestions that end users can disagree with. We'll talk about that tomorrow. So I go ahead and set it and punch in and say, hey, here's the site list I'd like you to use. This one happens to just be pointing right to my desktop. Use this thing right here. That's what I'm going to use. And then I'm going to force it to immediately refresh. By the way, these scripts for the IE side are all posted on my blog. You can just add an entry where you replace the word Internet Explorer with the word Microsoft Edge, and boom, the exact same PowerShell scripts work there. This allows me to force an immediate reread of what's happening, at which point then I can go and navigate to a site that is on this site list. So what is on this site list? I have taken the site zombo.com and said, this one I want to open in IE. And the experience of getting there has drastically improved. And actually, let me see if I can get, where is the audio plug for up here? There we go. I'm not sure if we have the audio turned on. Can we get the audio turned on from the PC? Is that something good? Yeah, you'll like this. This is really good stuff. So if we go here, it'll, oh, that didn't work. Did I reclomber? And that's always the fun part of. It doesn't need a GP update force because I'm punching it directly, and then I hit remove. Ooh, what happened here?
This is ZomboCom. Welcome to ZomboCom.
Yeah, this is ZomboCom. This will be our background music. Ooh, doesn't exist. That's fascinating.
The only limit is yourself. Welcome to
All right, so those are all right. Those should be gone. So this should refresh. Let's try this again. This stuff really does work, folks. Except not today. That's awesome. All right, let's go and kill off everything. Let me make sure I don't have any random things. Where is it? Do I have any edge hanging around here? Because it's going to reread it every time it opens. So now you get a free debugging demo, too. This is how to debug the enterprise mode site list, an unplanned debugging demo. There's never such thing as a fail demo, just an unintended debugging demo. So let's see if we have, I don't see any, let me actually just look for edge. What is it? Don't see anything, so let me try this again. All right, so that's not working well.
Welcome to ZomboCom.
All right, so first of all, I'll explain what ZomboCom is for everyone who doesn't know. Back in the era of Flash-based website introductions, you always had this little Flash introduction that coming in. ZomboCom is literally just an introduction that never has a site. And it's been around for years and years. It's not bouncing me for some reason, and I'm not sure why. I'm going to kill off all of my IE instances and see if that helps us. And then I'm going to stop the unplanned debugging demo, and we'll carry on with a non-local one. It does. I did this. I tested this last night. Yeah. So I'm not sure why it's not picking this up. Here, let's rerun and make sure we don't have any errors here. Should be poking all in. All right, final try, and then we're out, and I'll actually go and poke at some public stuff. All right, that's awesome. Okay, so trust me, that will eventually work. And we'll show you the experience via some of the public sites. So in addition to having this managed via the enterprise, this is how we manage the experience for public-facing websites. If you go to About Compat, you will see all of the websites for which we are specifying, hey, should I open in IE 11? Right? And true means yes, I'm going to do so. Right? So if I pick this one, aer.microsoft.com, the experiences now will automatically pop open a window and navigate directly to there. That is exactly the experience you get from your own site list. So from a user perspective, yes, a new window popped open, but I didn't have to think about it. There are also some sites that we don't automatically bounce over to. So if I pick one of the false ones, and here's one right here, that is set to false, and navigate there, that's when we get the, hey, you found some vintage web tech. Would you like to, and it's offered as a choice and not demanded. So in the enterprise mode site list, you get the auto bounce. In the public site list, there's ones that suggest that you might want to, but you can choose not to. So we've been working on improving the experience so end users don't feel like they have to then click an extra button on the way to getting their job done. Just the right window opens and they can start doing work. Right? So that's the intent. So leveraging the enterprise mode site list, right, when we look at how successful customers have been, I have yet to meet a customer who's had more than 4 websites verified, or web applications, not work using some configuration of the enterprise mode site list. So really effective. With this ability to bounce back to IE 11, a one-time task of find all of the sites that need IE 11, all of my ActiveX controls, I can leverage the enterprise mode, there's the enterprise site discovery toolkit to catalog the sites that use ActiveX. I can catalog the sites that use legacy document modes and use that input to build up my enterprise mode site list. And now I have, in essence, what is a to-do list. Here's all of my legacy websites. I can work this list down to 0, and once it gets to 0, I can use Edge for everything. More importantly, I can use any modern browser, ideally, for everything. Because today, if it needs IE, that means it's not working on your users' iPads or Android devices or phones. So really important. A powerful toolkit to address compatibility issues to help unblock and unlock getting to Edge. And that's the goal. So compatibility is one thing, right, that helps us move forward. Easy, manageable, apparently sometimes works. We can do the troubleshooting on that later and have some fun for anyone who's interested in following that up. But I want to now talk about, well, why on earth would I bother to go there? Because compatibility is one thing, but I need to have a reason to want to get there. I don't want to move just to move. Right? And the one thing that I would say is that if I am today going to say IE is going to continue to be my standard, you can kind of get away with it. Because most stuff works in IE 11, modern web stuff, IE 11 mode is reasonably good. It was pretty good at the time we released it. The problem is not going to be right now. The problem is going to be in 5 years when you have to go and pay back that technical debt. Because the web's not going to stop moving, but IE 11 is. There's no new investment in web technology. So as new web standards evolve, change, they won't be reflected in that platform. So you're going to have yet another legacy web that's expanding. You're also going to miss out on a lot of the work that we've been doing in this space of security. You heard about something that's coming during the keynote, where we talked about how we're going to allow the same sort of virtualization containers that give us features like Device Guard and Credential Guard, and having Hyper-V provide that hardware-assisted assurance of a security boundary between two things, applying to the web browser. And there's already stuff today that you're going to miss out on. So to set a little bit of context, how many of you are security nerds? So a handful of security nerds in there. Right, so security nerds obviously don't need to hear this, and I don't, probably not too many people at this conference that need to hear that security is kind of a big deal for the web. Here's how I like to think about it. right? We've just gotten really, really good at automating how do we take people down. How do we rob people? It used to be if I want to rob someone, I had to get a gun and go up to them and rob them. I could do one at a time, so maybe if I get really, really efficient, I might be able to rob maybe 9, 10 people a day, right? And depending on how much money they're carrying, right, maybe that's $1,000 a day if I'm pretty lucky, right? I'm pretty constrained on how much I can rob people. Then there came a great innovation in technology that allowed me to get way more effective at robbing. That innovation was the train. Now I can just stop a train in the middle of nowhere and with my same guns rob the entire freaking train. Now I got 200 people in one fell swoop. Technology magnified the impact of the robbers. And today a robber can go after the entire internet. Billion people at one shot, right? Automation has magnified the power of robbery the same way it magnified the power of everything else, right? And the web browser is the mechanism by which a lot of adversaries are getting in. Web browsers and email, the two things we concern ourselves with the most. So obviously we want to have a really good foundation because this is a lot of surface area. And when we think about, what is it that adversaries are trying to do, there really are kind of two different categories of attacks that we see people doing. Number one is, I'm going to go after you. Something like Stuxnet, where it's like, I'm going to try and shut down a nuclear reactor in this country. Or I'm going to try to get into the Department of State to get at this database, is a very targeted attack. I know exactly the asset I want. I know why I want it, and I'll go get it, and I can find out about those people, versus the, I'm going to send a link to a website to a gajillion people and hope for the best, right? A really, really effective business model was the navigate to a website and a window pops up saying, hey, would you like to buy a nice fresh copy of this security software that will clean up your horribly messy computer? They made tens of millions of dollars doing that. So targeted, large scale, both of them very important attack vectors, and we think about those, and our adversaries are getting a lot better at finding vulnerabilities. In fact, it's really interesting to me as someone who works in the field of security that we have to figure out, how do we work together as bad as the bad guys, as well as the bad guys? Because think about it. What typically happens when you're having security conversations and you have multiple vendors in the room? It almost becomes like a contest. Who's smarter, who's better, who's going to do what? We're much better at fighting with each other than we are at working together. Oh, you need my thing. My thing's the best. My thing will cure all of your ills. We don't work together. But think about what our adversaries are doing. Our adversaries have built up an entire digital economy whereby if you come up with an exploit, you can sell it. And if you're not smart enough to make the exploit, but you're really good at getting people to click it, you go buy the exploit and you put it on a whole bunch of emails and you gather some assets and then you can sell the assets. You've got an entire economy underground that operates in a world of inherent distrust. Think about it. By definition, everyone in this community is a criminal and can't be trusted, yet they work together. And they're working together with increasing effectiveness. So we need to do better than that. We need to figure out how to solve that. And this is what we're trying to do, is look at, hey, they're getting really good. How do we start closing that down? And we close that down by looking at taking entire avenues of attacks and shutting them down. So rather than, hey, here's this one pinpoint exploit, plug that hole like the little boy in the dike, and then plug that hole and plug that hole. It's like, you know what, let's rebuild this wall. And there will be other walls. Right? As I like to describe, if you have 10 doors that are open and leaving you vulnerable to security issues, you could either go to all 10 doors and close them a little bit, but they're still all open. Or you could close one door completely, and now you can pay a whole lot more attention to the other 9. And it turns out that closing the one completely has much better outcomes. So that's why we looked at shutting down entire categories of attacks. So historically, we said, let's take what kind of memory exploits people are doing. They're just putting stuff on the stack. They get to know where we happen to drop kernel 32. They find a bit of code in kernel 32 that does what they want to. They get the instruction pointer pointing at that code, and bang, they're running what they want to do. How do you fix that? Well, you move stuff around randomly in memory. You also look at how do I get you from pointing the instruction pointer at code that you stamped down there. Data execution prevention helps to prevent that, and that was a really big barrier. We got that turned on in Internet Explorer 8 only by going in and putting in a mitigation into the operating system itself, right? Because I don't know how many of you are familiar with sort of the ins and outs of data execution prevention and what enabled that, but we had to add a new Windows API that would do some specific thunking, and here's why. Turns out there is a particular library of Microsoft's that shipped that wasn't data execution prevention compliant. And it wasn't because there was no dep available when we wrote it. That tool is ATL, which stands for the ActiveX template library. What do you think people built with that? Turns out they built ActiveX controls with it. So none of them were dep compliant. So we have to actually put in some APIs to allow us to turn on dep in the browser to work around those legacy ATL-based ActiveX controls. So we did turn it on by default and reduce the surface area. But then people figured out new ways to get around it. All right, so, well, if you're not going to let me go to this one particular spot, I'll just start spraying stuff everywhere. What do? We add more entropy. We look at other things we can do to extend, how do we keep things put in place? We really worked on forcing ASLR into things that weren't even expecting it and start to shut that down. And then we find, all right, well, I'm going to look for other ways to do disclosure, and we look at additional configurations such as control flow guard to go against the ROP or return-oriented program style of attacks. We're going to go into details. I want to explain a lot of the things we show on marketing slides as we go to make sure everyone has that baseline. So what are some of the things that we're doing, right? And this is all sort of the, hey, we want to make a really good browser by eliminating vulnerabilities, eliminating classes of attacks, break the techniques, contain the damage, soften it out. Here is a big one that's different. We put Microsoft Edge into an app container. Now, how many of you know all the details and ins and outs of what an app container is and why it helps you? Literally 0 hands up. So I want to explain what an app container is. And to explain what an app container is, I kind of have to start with everyone's favorite feature of Windows. And that is UAC. How many of you love UAC? Round of applause if you love UAC. All right. That did not happen in 2006. In fact, that was, all right, I may get in trouble for telling the story in a public forum, but it's too good of a story. So a really good friend of mine was the guy, one good friend of mine came up with the idea that became UAC. If you look on the web, you can still find a script called Make Me Admin, written by my friend Aaron Margosis. He wrote this script, and the UAC team, well, let's just build that, and we'll just build like an industrial strength version of that to make it. And then another good friend actually ran the engineering team that built it. So when Bill Gates, when he was retiring, was asked, what 3 things would you have not done in your career if you could go back and change things? One of the 3 things was UAC. And he's like, really? You had to say that? But it's become something good. So we kind of have to understand what's going on in UAC because it is fundamental. So I'm going to go ahead and start with a couple of different command prompts. One with me running not as admin, and one with me running as admin, or actually technically one is as restricted admin, the other one is full admin. And I'm going to use whoami/all and just dump aspects of my token. Right? It usually takes a minute to run. Right? And the big difference between the two is, well, it's the same me. So if I look at the SID, they're absolutely identical. There is no difference between the 2 versions of me. But as these start to expand out, I will notice that there are some very important differences, right? So UAC, people think of as being the prompt. And it's not just a prompt, right? UAC, when you are an administrator, is a convenience feature. It is designed to make it easier for you to look like what standard users look like. It is not a security boundary. If someone gets past the UAC security boundary, we don't make any commitments to fix it, right? UAC is just designed to make it simple to do that. The idea and we will eventually get to the point of expanding, now it's going to blow right through, is that this unelevated window is what we expect the typical user to look like. There's a few privileges that allow you to do tasks that affect everyone, really. And really the core principle of what a standard user is, you can really distill down into one summary statement. Standard users can mess up all of their own stuff. Administrators can mess up everybody else's stuff. That's the difference. So what are some things that we need to let you do as a standard user that might mess up somebody else's stuff? Well, you kind of need to shut down your computer. Clearly, if your computer turns off, you're going to impact other users on the computer. But if you can never shut down your computer, it's not a very effective device, right? I can't turn it off ever because that's an admin task. Or undock it. I can't walk away from my desk with it. So we have a privilege that says, yes, we know this violates the boundary, but you have the privilege, you're allowed to do it. One of the big changes we made for Vista was you didn't used to be able to change your time zone. I got screamed at by a woman in a courtyard in Minneapolis who was like, we're running a standard user and I can't change the time zone. I'm like, clock's always wrong. She had a point. So you have a privilege. I don't know if it needed a whole privilege, but now you have one because changing the system time is an admin right. If I change the system time, what can I do? Change the system time to 4 hours from now, do the bad thing, change the system time back. Now my audit logs are going to say the bad thing happened at 10:51. I make sure I'm in a public space really far away and noticed by lots of people, so I have a repudiability problem. So changing the time, admin right, not doing it's there. You still have all of the other privileges that are there, right? This is the unfiltered token. It shows me everything. The other important thing that I see is this right here. Mandatory integrity. So this is a whole new concept. This is part of the UAC framework, and it's part of the original sandbox that we had starting in IE 7. We called it Internet Explorer Protected Mode. It's called the integrity level. It allows us to do an access check based upon how much you trust the process in addition to your identity. Every process has an integrity level, and every kernel mode object has an integrity label. High, medium, low, system. There's 4 that are primarily used. Technically, it is a 32-bit number, so there are 4 billion possible options. 4 we figure is probably about enough. That's all we need. So we've got a lot of room to grow if we want to. If I run as admin, I run as high level. If I run as a standard user, I run as medium. And we used low as our sandbox. So now we're down at low. So if I run Internet Explorer today, it will be at low integrity. Now that low integrity sandbox allows me to say, I cannot write to anything else. And we can see that. If I go in and create a process with low, I'm going to go ahead and do a ps exec and launch Notepad in low integrity. And I can verify what it is. I can use Process Explorer and say, oh, here's Notepad, and I can go and find the integrity level, and it is, sure enough, running in low. So I've got low integrity Notepad, and I can create a test document, and let me go ahead and save it. And I'll put this in my documents folder. And actually, let me go and clean up. I was doing my run-throughs yesterday, so my documents folder still has all these from samples. Let's create it as lowintegrity.txt, just so we can see it. And I can, because the default marking is medium, no write-up. So I can't write to it. That's how the sandbox works. If I'm in low, I can't write to anything marked as medium, and the default for everything on there is medium. That's how we protected it. You can also see why you should never trust an error message. Hey, you see you can't put it there. How'd you like to put it in your documents folder? That sounds like a great idea. Please put it there. Well, you can't put it there. How about the documents folder? That's very helpful. Never, never believe, if you actually want to see why, the most extreme example I've come across so far of when not to believe error messages, search on my blog, which is at appcompat.guy.com, for MATLAB. There's a version of MATLAB that if you don't tell it you're Windows 2000, will spray your screen with the complete stack dump. That is its error message, which is its way of saying, I really kind of wish you were Windows 2000. So error messages can't necessarily be believed, but that's the problem. It can't write there. Now, if I wanted to write there, let's go ahead and go into Explorer, into the Documents folder, and make a new text document, lowintegrity.txt, and then show you the interesting fact about it. Let's go ahead and open it. So here's low integrity. Oh, that's not what I want. I want documents. Lowintegrity.txt. I can read it. It's mandatory integrity control, not mandatory privacy control. I didn't stop you from reading whenever you want to. So if you're trying to steal something, our sandbox didn't keep you from reading it. It kept you from clobbering it. Important thing to note. Right? So I can open it, but again, I try to save it, I'll run into all of the same problems. Hey, I can't save there. So what I'll next do is get a new command prompt open, because that one's still waiting on it. And I'm going to go ahead and I'm going to get the documents folder. CD documents. I'm going to use a utility that my friend Mark Manassi wrote called Chummel, which gives me just a quick and easy way to not have to write code and change integrity levels. For low integrity at txt, and set the integrity to low. So now it is marked as a low integrity file. And now I can save it. Problem solved. So that's the legacy sandbox. Put you in low, and then you can't write to stuff, which is good. It's definitely a step in the right direction. It definitely helps protect you. It reduces the impact, unless the impact you're trying to mitigate is privacy. But then you run into a bit of a problem. There is one low integrity. So we started off, it was just IE. And then Office said, hey, that's a really good idea. You got all the stuff coming in from the web, and who knows what's happening in there. Let's make sure that those macros can't clobber you and start, I don't know, encrypting all of your files. Let's take anything with mark of the web and open it in protected view, which is low integrity. It won't be able to write to it. So now Office is down in the cesspool as well. And then Chrome, well, Chrome had to one-up us, of course, so they said, oh, I don't even want to do low. I'm going to do untrusted, which is an integrity level of 0. Same idea, right? So if anyone else chooses 0, they're now in the cesspool with them. There's one cesspool. It's basically everything below you lives with you. And what if you don't trust all of your neighbors? What if you're like, hey, I'm the browser, and those Office guys, I kind of don't trust them. I don't want them to jump from me to Office and then back out through Office. That's a threat vector. I want partitions. So that's what we were trying to get, is some partitions between them. So we look then at building up the app container. And I'm going to, unusually for an IT Pro thing, we're not going to actually look at the code, but I'm going to open up in Visual Studio, wrote a demo that I'm just going to launch. I'm not going to go through the code bit. And have an app that's written for the Universal Windows platform. Now, so first things first, I will say, I probably, like you, do not understand why we have renamed this platform about once every 18 minutes. The platform formerly known as Metro, formerly known as Store Apps, formerly known as Modern Apps, formerly known as Universal Windows Applications, I guess now known as the Universal Windows Platform. It's had 900 different names, all the same platform. It's all the same thing. But I'm going to look at one thing, which is I'm going to try and write to a file. Now, if I look at this process here, right, let me pull up here, App Container Demo, and I'll look at the Security tab, and I can see, aha, here's an integrity level, and it's at low. I know how to fix low integrity files. That's an easy one. So let me go fix that. Right? So I'm trying to write a file. The file is called sample2.txt. So let's just go back in here and make that file, so it's already there. So new text document, sample2.txt. And we also know how to do Chummel, so we'll just change Chummel and say, all right, let's set this sample2.txt, set it to low, and now We've solved the low integrity problem. We've gotten out of the sandbox. Everything's awesome. Except I still can't write to it. Because the other thing we've added is not just low integrity, trust-based authorization, but we've also added in the ability to have an identity for the app itself. And that's called the app container. This SID is specific to this app. It's generated based upon its name, based upon its publisher. That's why it's important. If you're a given name, given publisher, we'll validate this for store apps to make sure it's the same one. If you're building them for side loading, make sure you have some scheme to make sure you don't replicate it, because that, in essence, inevitably becomes a problem. This is the identity of this app. I can do authorization based upon this particular SID. And if I don't have permission as this app container or as one of all app containers, I can't write there. That's my partition. That is checked. We see that it has an app container SID, and we enforce this rule. So if I wanted to allow it to write there, I could add the specific SID. That's a lot of typing for me, so I'm just going to short-circuit that and say, go into the properties, go into security, edit the access control list, add an entry, and I'm going to pick the locations. It's going to now enumerate everything on my corporate network. My favorite part of this bit of UI is you're waiting for that. Say, I want something local. Go to Advanced and show me everything that's on here. I have this entry. It says if you're an app package, an app container, you're okay. I can do all of them. I can do one of them by SID. I'm just going to do all of them, because you'll get the idea. App packages can do it. They'll have full control. And now that I've done that, when I try to write to this file, it works. So now I have division based on trust. Now you're down and low. And I've got partitions between you. You can't crawl around between them. It will impact read. It will impact write. And it becomes much more powerful, a much stronger isolation between objects. I can control it. I can treat them like a job, kill them off as one. It becomes a very powerful construct to allow me to separate what I've built. So when you create the application, it will generate a SID. For that, there is a built-in group which consolidates all of those. And you'll actually notice there's been quite a few of those umbrella groups that combine a bunch of undefined things, right? So there's a well-known SID that's for all app containers. There's a well-known SID for all local users. There's a well-known SID for all local administrator users. So even if you add more, it just automatically gets computed, and that's one of them. So there's a well-known group for all app packages, and you have the SID for just the one. So we put it into an app container, and we can actually see what we're doing. Let me go ahead and close this down and take a look. We can actually use Process Explorer, which has full knowledge of what's happening. We saw it, and let's use it against Edge. So we open up Edge, and we'll go ahead and take a look, and we'll find, all right, so here's Edge's content process, and I see if I take a look at this content process, which is where it's being put together, I have, let me make this big, an app container entry. So Edge is living in an app container. It's partitioned from everything else at low integrity, which it also is labeled with. And something that we added for Anniversary Edition, or Redstone 1, or RS1, or 1607, if one name is good, 3 is better, is that if you go to a site that has Flash, like CBS.com, still uses Flash. If we take a look, we've actually created a new process. And I can tell which one is the Flash process. That is not it. Let me actually sort by name and make sure I get it. There'll be a new process, and it will say DC host. So that's one way of spotting the Flash content process. It's separate. That's important to note. The other way to spot it is that it will have in the list of DLLs flash.ocx living within it. If you are Flash, we now run Flash inside of its own app container. Technically, it is a child app container. So if we look at the app container SID between them, that's sort of the one bit of evidence we have. I actually just had a conversation with Mark Rusinovich earlier to say, wouldn't it be awesome if we could look at the relationship of child app containers? And he said, yes, that would be awesome. What's the API? And I said, I don't know. And he said, that's not very helpful. But you can start to see the relationship, like, 362.405, and if I do the same thing here, where did my app container go? There we go, app container, 362.405, right? There's a relationship, and they diverge as we get to the end. It is a child app container, so the parent app container can control it. It is secured, so it is separate. The Flash content is actually separate from the rest of your content in the browser. So we have that additional separation for what for many is a pretty big risk vector when they have a lot of Flash within the environment or they consume a lot. For example, EDU, educational facilities, often have a lot of Flash-based content, right? I've seen a few banks in Australia in particular seem to have a lot of Flash-based content based upon what they're doing. So we now have that additional isolation using those app containers that allows us to further isolate the process and mitigate the damage so that even if someone gets code running, there's not much they can do. They can go and mess with other Flash bits, and that's all they can do. And that's the intent. We know we can't stop everything, so we want to make sure that we stop the most important stuff. What other things have we been doing? Well, this one doesn't really need a demo. We went to 64-bit everywhere. And if you look at kind of where we came from as we go across, so app containers you actually could get on IE. It was called Enhanced Protected Mode. And in Windows 8, we actually shipped it for a couple of months on by default. And then we kind of went, oh, crap, that kind of broke everything. Let's turn that back off because everything broke. But you can turn on Enhanced Protected Mode and break everything. And since IE at this point is just a compatibility mitigation, I kind of don't know why you do. I'd be curious if you have a scenario where you would enable that. I don't know why you would, but you could historically. 64-bit, same thing. Historically, you used to be able to launch it. That was one of the big confusions people had. I'm running 64-bit Windows, and I have two browsers. And depending on how you build it, there's actually an interesting problem with deployment tools that would sometimes pin the 64-bit one, which is basically the don't let any of my internal apps work link. By default, and it was really painful to get it back, switch back to the 32-bit when you could, but it took a whole bunch of steps. Because 64-bit means if you have ActiveX, they all have to be compiled for 64-bit. And at the time when we first put it out, there was no 64-bit Flash. There was no 64-bit Java. And that was the stuff that really mattered. And certainly custom-built ones, no one was doing a separate compile for 64-bit. We don't have plugins using ActiveX, using native code in Edge at all, so we can just say 64-bit all the time. And that helps to get by some of the mitigations, some of the attacks that people would use of just spray stuff everywhere, because everywhere used to be kind of big, 2 gigs, it's a lot of space, but you can eventually spray it all through. The 64-bit address space is really big and really hard to spray everything if that's how you're going to go through and do an attack. Turns out to be a really, really effective mitigation to help move people, to help address some of the attack strategies that adversaries are using. We've done a lot of work in terms of going after a category of attack that's really prevalent, which is called use after free. Use after free, I can explain what that is, right? And this, I think this one's hard to explain to people who don't write code, but I'll do my best if you're not a developer. The idea is this: you've got a bit of memory that could be referenced by something. JavaScript is a garbage collected language. So if I have a bit of code over here in A and a bit of code in B that are referencing this bit of memory, well, here's what I could do. If A frees it, and we don't correctly track it with our garbage collector, we could put other memory there. Allocate it, put some stuff in there, and then when B references it, now we're running that code that I, as the adversary, put in place. So I've used it after I freed it. So a lot of work went into improving the garbage collector, so it wasn't just looking at a couple of places to say, is there an immediate reference before I go ahead and put this as, hey, you can go ahead and allocate this, that we have a much more comprehensive list of things we look at to say, is that really free? So we can spot that B still has a reference to it and not get rid of it yet and not let you write there, be unable to allocate that. So it's on the garbage collected heap that now does a far superior job to what we're otherwise doing. So now when you free it, you still can't write on top of it. And that allows us to really contain what was a very, very common attack vector that people were using to exploit the browser. Another big thing we did was, let's get rid of a lot of the stuff that's not there. And this philosophy cannot be overemphasized. I work with people top to bottom, desktop down to the device level, up to the Active Directory level. And the number one recommendation we have is reduce the amount of stuff you have to make it more secure. Right? So when we talk about, we have this concept of a tier model and how we think about security. Tier 0 is your identity layer. Tier 1 is your servers, your services, be they in the cloud, be they on-premise. Tier 2 is the workstation, the device. That's kind of the initial framework and a taxonomy that we use. And we would say your Tier 0, your identity layer, what has your Active Directory and has control over everything, right? The skeleton key to everything in the kingdom. The number one way to secure that is make it really small. Don't have, how many of you do IT? All right, it's a lot of IT folks in the room. Tell me what you think about this idea. I ran into a customer that happened to have an agent running on every single desktop, every single server. The agent was a member of the domain administrators group. That's a very, very large Tier 0. That's a bad idea. The smaller it gets, the better, right? So we would say Tier 0 should not be sharing a virtualization fabric, should not be sharing antivirus administration, should not be sharing backup administration, should not be sharing shared storage, right? This whole list of things to say it should be as small as possible and easier to contain. And the same thing applies here, right? There's this historical legacy way of thinking that says the more software I have on here that has the word security somewhere on the box, the better off I am. And if you've been reading the papers, you'll realize, oh, it turns out that some of the security software I have has remotely executable or RCE class bugs in it, which means now because I have that software installed, someone can compromise it. The less stuff I have, the better I am. So we're like, let's get rid of stuff. So IE was great for compatibility, but had more surface area because when we looked at enterprise mode, all the different things there, what actually happens is we can behave in 11 different ways. That's 11 different code paths that have to be protected. And a lot of them, for compatibility reasons, we can't put in the same level of fixing, right? Obviously, we try, but it's a lot of surface area. So we've got to figure out how do we work around to get them all equally safe so you can't just request a document mode that gets you past some security bug. So we get rid of the legacy document modes. We get rid of a lot of the legacy script engines like VB script, right, which is not a web standard, and move forward to having true standards everywhere. Get rid of all of the browser helper objects, the ActiveX controls, in essence, that were being used as software distribution to reduce the surface area. Had a huge impact because that's what we see people using, right? And there's been ebb and flow. If you watch sort of what happens in terms of vulnerability, I look at folks all the time and meet with folks and talk about their security concerns. I had one security person who said, listen, my concern is 0 days. I'm worried about 0 days, someone coming in and exploiting it. Anyone know how much it costs to buy a Windows 0 day today? It's probably $50,000 to $100,000, right, for a really good one that works on a whole bunch of different levels, right? That's how much it's expensive. You know how much it costs to buy an exploit for Java 6 Update 22, which is what that customer happened to be running? 25 cents, actually. I didn't find a $0 one, but I found one for a quarter. No one's going to spend $100,000 when they can buy something for a quarter. We got to get rid of all of the quarter exploits and move towards, hey, I'm going to make you spend that $100,000 if you're going to come after me. Reduce that, and then we look at code integrity. And this turns out to be a fairly hard nut to crack, right, until we start looking at enforcing what DLLs can get in there. Because with ActiveX, I can inject arbitrary DLLs in there. By definition, that's how it works. But what we can do with Edge is we can say if you are not digitally signed, and we can enforce that through a hypervisor. We can use the same mechanisms we do with Device Guard. We have all of this capability to say you have to be signed by Windows or you don't run an Edge. Kernel mode, user mode, we can put in that enforcement. So there is not another DLL. Even a debugger cannot inject itself into that to increase the security. Kernel mode and user mode code integrity are built in the Edge. We talk about how we're going even further than that. When we look at what's coming in Redstone 2, whatever that one ends up being called. We also look at addressing return-oriented programming through Control Flow Guard. Now, how many of you have heard the term Control Flow Guard? All right, a good number. How many of you could explain to the group what that is exactly? So for the remote audience, there are exactly 0 hands up in the air. Because we started talking about it as if it were obvious to everybody. And it is not obvious to anybody. There's a body of research out there about control flow integrity. You can go and read the academic papers. And it turns out to implement full end-to-end control flow integrity, you're looking at a performance cost of about 50%. So you make everything 50% slower to do a full end-to-end implementation. And it turns out to be really hard, but it's possible. And you can really put in some super strong protections. But it turns out even more to our benefit that you can with an O of 1 operation. So for those who didn't do computer science studies, right, O of 1 means it's constant. No matter how many things you're doing, it will always happen at the same speed. A quick evaluation to say, are you a safe place to jump? So let's take a look at that. Let me switch over. And this is the bit where I'm going to try and take, we've got just a handful of developers in the room. How many of you have written anything in assembly language, say, in the past couple hours? All right, so again, I'm going to, for the audience, about half of the hands in the audience are up, right, for the people who aren't here in the room. Or maybe not. So let me go ahead and clean up the desktop here. I've got an old notepad running. I want to show what this is. All right, so let me go ahead and open a solution and show you a bit of C++ code because, hey, why not? We're IT pros. That makes a whole lot of sense. The real bit is with this code here, we're not going to focus on the code. You don't have to read this. You don't have to understand it. What I am going to do is I'm going to open up a couple of command prompts side by side. I'm going to show you, and I think I can take, and I've done this with Microsoft salespeople who didn't really appreciate having to look at assembly language, but they actually got it. So I am confident that a group of really smart people who have their souls will be able to, I'm sorry, did I say that out loud? Demos, CFG, right, and I'm going to have one binary where I disabled it. Open the disabled one, right? Whoops. That is, I'm just making sure I don't open the same one twice. That would be bad news. CFG disabled, yes. And open it in a debugger. And then what I'm going to do is I'm going to just quickly unassemble the function. So real quick, for anyone who wants to fiddle around with the debugger, this is just the Windows debugger. This is a command line one because it's easier to do 2 side by side for me. Unassemble the function. So CFG demo, bang, foo. UF, CFG, demo, bang, foo. So 2 functions. And you're like, all right, 2 things compiled 2 different ways, and wow, they look kind of identical. And they are. They're 100% identical. There's nothing different between the 2 compiling, right? So they're going to run at exactly the same speed. here's the other thing I did. I'll see if I can explain this. In this function, I took, as an argument, a function pointer. So I'm basically saying, call whatever function you gave me. I don't know, which means I'm saying, take an address in memory and stick my instruction pointer and start running that code. Because that's what I want to protect against. Because if I'm the bad guy, I want to rewrite that address to point at my code. So you're pointing at arbitrary code of the attacker's choice. That's what I want to do. That's my attack vector. Well, here's what CFG does. So we can actually finally explain it. So I'm going to unassemble CFG gemo, bang, indirect call. Direct call. And unassemble function, CFG demo, bang, indirect call. Now they look mostly the same, but you can tell straight away one's a little bit longer. Here's the difference. What I'm doing here, without control flow guard, is I'm saying call a function, whatever's in this address of memory. Right? These brackets mean just go look here and just point the instruction pointer there. I'm going to start running code there. What control flow guard says is, hey, you know what? Before I do that, let me take that address and check to see if it's OK. When you compile it, right, with CFG enabled, we'll go through and look at every single function that you, the developer, put in there, all of them. And we'll make a bitmap. And we'll say, this address, not a function. This one, not a function. This one, not a function. Here's a function. This one's not a function. It's not a function. Here's a function. So we got an address table of everything that's OK. So all this function does is say, hey, what address did you ask for? Is it marked yes or is it marked no? If it's marked no, we'll fail, we'll crash, and out you go. If it's marked yes, we'll run it. That is control flow guard. Are you a safe one? Are you not a safe one? So if I'm an adversary, I pop in a new address there. It'll check. And if it's not a legit function, when I compile the application, punt, out it goes. How did I do? Did I actually successfully do an assembly language demo for the browser, or is everyone going, what the hell just happened? Good. I got a couple thumbs up. But that's why I wanted to show it. I'm like, it's really straightforward when you see it at this level. I thought it made it a lot more human to me to have actually done the compile and see it. And that's what we're trying to do. Now, the one thing we're not doing is we're not checking the ret. Right? So that's still an area where we look at how can we do that. So when we think about engineering-wise, the problem right now is that that turns out to not be an O of 1 operation. It can't be done in constant time. Right? So we're always worried about the trade-off between performance and security. And that one is really high overhead, a lot of complexity, and complexity is usually bad. Doesn't mean we're not working on it. But that protection breaks an entire class of attacks and is really powerful. We also look at how do we protect what's going on in the kernel. Because as the application layer gets harder and harder and harder, people look for other soft spots. Hey, you know what? Your defenses up here are pretty good. I'm just going to poke something further down. So we did, same idea, attack surface reduction. So if I'm coming in from edge, historically, I would be able to go in and look at every single function exposed by the kernel. It was all inbounds. So if I'm the bad guy, I just find, hey, this one's got a vulnerability in it. I can actually hit it from the browser. Right? So finding the vulnerability is one thing. If I can start executing code in your device by emailing you a .exe, I can trigger it. But what's even nicer is if I can get you to navigate to my site and poke that vulnerability, that's good. So how do we protect against that? We have an entire class of system calls that we filter out. So if you have a function that, in our instrumentation, is never used by the browser in legitimate use case, and because we don't have plugins, we don't have arbitrary Windows 32 or Win32 code running in the process, which is what you had with ActiveX, once we've instrumented, once we know what functions are ever called, we just say the rest, which is about 2/3 of them, never call these. So if there's a hole in one of those 2/3, Edge is never allowed to call it. And in every other app, it would be. Further attack surface reduction. Again, another really impactful way to go through and put in protection. We also look at things like Smart Screen, right? And Smart Screen is something that, as a nerd, it's like, I kind of, to me, it's a good argument why you ought to digitally sign stuff, right? Here's the idea behind where Smart Screen is today. So Smart Screen today, it has an element of, let me go ahead and quit and exit, and quit and exit. It has an element of blacklist, right? So if I do a search for Smart Screen demo, it's going to go in and find a little thing here, and yep, this is known to be bad. And interestingly enough, it's going to say, hey, that doesn't look so good. Are you sure you want to go there? And if I say, yeah, go ahead and go anyway, it'll be like, oh, you know what? This is known to be bad. It's been reported, right? That's my blacklist. Now, blacklists, as we all know, blacklists don't really work anymore, right? That's sort of one of the interesting things when it comes to security is, what did we do 20 years ago? What was security? Buy an antivirus. Get rid of all the bad bugs. In today's world, how well does that work? In a world where over 99% of all adversary activity is not using malware, but is using inbox tools, once they get their foothold, they just use the stuff that's already there and already on your whitelist. I can't just use a blacklist. So what do I do? We think about reputation. So if I'm an arbitrary executable on the internet, I have to earn a reputation. Because not known to be bad does not mean good. But if lots and lots and lots of people download it, and none of them report it as bad, you're like, we seem to be building up some evidence that this probably isn't bad, right? If I got 4 people who've ever downloaded this binary and no one's reported it bad, that's not a very big sample size. I might want to give you a yellow warning and saying, hey, you know what, this is pretty infrequent. Are you really sure you want to do this? If I've got 30 million people who've downloaded it and everyone's like, it's fine, it's probably fine. I don't know for sure, right? Maybe it's just really stealthy, but at least I built a reputation. Now, if I'm not digitally signing, and I cannot stress enough the importance of having digital signatures central to every software that you use, every software that you build, every software that you buy, digital signatures collect a reputation. So when Adobe, day one, when they released the new version of Adobe Reader, we don't want to say, oh, I don't know about that. It's like, you know what, Adobe Reader's probably fine because the Adobe certificate has trust. There's like a gajillion downloads of Adobe software, so Adobe has the reputation, right? Whereas brand new file that I post on the internet has no reputation yet. I might want to say, yeah, this is kind of new and novel. It's not signed, so I have no idea what's going on. This concept of reputation is we continue to try and find ways to let people make smart choices, right? To help protect against, a lot of these, socially engineered, I tricked you into downloading something, let me at least give you the best warning I can, or actively block you when it's known to be bad. We do a lot of work internally on the team, right, in terms of how we do development, right, so that we can do our own fuzz testing. There's some great announcements, really exciting stuff this week about some of the stuff we've been doing in Microsoft Research that lets us do a lot more automation of fuzz testing. We avail ourselves of all of that. So we do really good fuzz testing, really good static analysis. We employ pen testers. We have people attacking our own stuff all the time. They find lots of stuff for us to fix. And it all ends up being good as part of our entire posture, which is really trying to be holistic. We want to not only protect and build a strong platform, but also mitigate so that if it ever does get compromised, the amount of damage that can be done is minimized. So even if we get popped, that the adversary can't do anything to stuff that matters to you. So what does that mean, right? We end up having a really good, solid platform. Let me actually bounce back in here into some stats. I had this one hidden because I had to verify this number, but I checked with my colleague Fred, who was, because the middle one is like, there are no known exploits in the wild of Microsoft Edge. And anytime you say a 0 number, it's like, you know what, let me make sure that was okay. So as of 11 o'clock this morning, when I verified with my colleague, there are no known. Is that right? Still? None have happened since 11? We're still good? All right, so no one's told. So Fred Pullen, by the way, he is the nerdiest product manager in all of Microsoft. And he looks after the browser in just phenomenal ways, as well as a bunch of other really interesting things. And so just is actually on top of and understands these things. No known exploits, the number of code vulnerabilities has really gone down because of these investments. And this is the payoff. This is what we're looking for. We want to give you an avenue where you can put the browser into an important high security scenario, because there's all kinds of stuff that the other guys aren't doing. And I'm not a fan of saying, there must be one and only one browser and blah, blah, blah. That's really not the way that I work. I have other browsers installed even on my computer, but when I'm doing specific high security things, right, if I look at what's going on, I have a sandbox. I don't have CFG. So current builds of Process Explorer, there's a column you can add to see whether CFG is enabled. And you can start checking up on folks. I check up on folks all the time. I'll sort by this and say, all right, who's got this enabled and who doesn't? And I'm like, oh, all right, so my phone doesn't have it, and is there any other stuff on here? I actually had not checked on Office for a while. I should probably go check up on then. But I can see all the Windows stuff definitely does, right? When I'm thinking of stuff that really matters to me, I want to have the best protections that I can. Right? All depends on my use case. If I'm just surfing for dancing monkeys, maybe it doesn't matter, but maybe it does. Thinking through the context scenarios. If I'm dealing with a high security scenario, I do a lot of those, I want to make sure I bring in the highest security that I can. And that's what we've tried to build. And from a product standpoint, if you're a security nerd or even a nerd in general, what we want to bring forward is, hey, this is a really great platform. It runs your stuff. If it doesn't, obviously you can't use it. We get that, right? And we want to take the feedback on what doesn't it do, while we continue to invest and respond. And I will say, I've been working in application compatibility and browsers and Windows and everything for over a decade now, because I'm really, really old. I've never seen the team in Windows listening more actively and trying to build stuff as they can. And the focus has really been on making this amazing security experience. And it is incredibly differentiated because of the collaboration we've had with our customers, with the security environment, and with researchers within the company to build something that truly allows you to have a safe and productive browsing experience. So thank you very much, and thanks for coming. Was it nerdy enough? So different plugs. So there's an ME deep dive for enterprise mode tomorrow at 12:30 for anyone who wants to go more into the compatibility side. More on the security side, I'm giving a talk at 9 o'clock tomorrow morning, so you'll be nice and hungover, on endpoint security all up. So Windows, inclusive of the browser, how to use secure endpoints. And if you want to go more into some of the hardware virtualization bits, Sammy Laho, who's an amazing speaker, is giving a talk tomorrow, I believe at this time, like 2 o'clock, on some of the hardware-based security, how that's implemented. I know he came in with a pile of kit to go through and inspect memory that caused him some problems at the airport getting into the country, which I found quite humorous. Hey, here's this Finnish guy with all kinds of hacking tools. What's this? This allows me to hack into things. Oh, really? Wait, hold on. You'll need to wait here, sir. So enjoy and have a great rest of the Ignite.